Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Mashid Mamburu. This lesson is proudly brought to you by the Gauteng Department of Education. Our WhatsApp interactive number is 064 748 8913. I repeat, our WhatsApp number is 064 748 8913. I hope we're going to have a nice time. We're going to do a revision of electrochemistry. Today we'll be focusing mostly on problem solving. So we'll be doing a lot of problems to give you strategies to say, how do you go about answering questions during these coming exams? Remember, we want 100% in paper 2 that we are doing here. So please, let's work together and let's enjoy our lesson. So without any wasting of time, we'll move. You will remember, learners, we are saying in paper 2, we have 2 knowledge areas, which is matter and materials, as well as chemical change. So today we'll be focusing on chemical change, which is 28 marks out of 75. Remember, paper 2 is 75 marks, so we're going to have 28 marks under chemical change. So that is our focus for today. And the paper will be 1.5 hours. I think you saw that during prelim. When it comes to our weighting, you have 30 for level 1 questions, which is just your recall questions, 35 for compression, then you have 30 for application and 5 for analysis, the last level 4 questions. So you must know that the difficulty differs in this way. So without any wasting of time, we'll move as I indicated. We said we'll be doing electrolytic cell and galvanic cell. So that will be our focus for the day. Now remember, in grade 10 learners, as I indicated, that the purpose of today is problem solving. So we're going to spend much time dealing with problem solving. So we're saying in grade 10, you have done what is called elements and compounds. I hope you remember them. And then you will remember that we said elements cannot be broken down. Those ones that you find from the periodic table, those are your elements. So we're saying elements are substances that cannot be broken down into simpler substances. For example, you can't break down, if I can write for you one element, zinc. You can't break down because it's only one, but when you're having a water molecule, for example, you can be able to remove oxygens and hydrogen to separate them. So you must be able to know that when you talk about an element, it cannot be separated, it cannot be broken down. But when you talk about a compound, it's when you consist of 2 or more elements. When you join elements together, they give you what we refer to as a compound. We have done all this in grade 10 and in grade 11. You revise that as well. So our focus today will be on substances. So when I refer to a substance, I will be referring to an element, a compound, and thirdly, an ion. So you got to know that if we are having an element and it loses electrons, it will ionize, it will become an ion. For example, if you are having sodium, when it loses electrons, it becomes sodium ion. So you know that when sodium loses an electron, it will become sodium ion. So when I say substance, I'll be referring to elements, compounds, and ions. So all the time, when you say what is a reducing agent, you are saying it's a substance that undergoes oxidation. So you will be able to know that a substance can be an element, can be a compound, can be an ion. So our focus will be on the substances. Now, as well in the previous grade, you were able as well to do naming of compounds, the negative and positive ions. Remember, learners, a positive ion, we refer to it as a cation. This is very much important for this section to know that we'll have negative ions and positive ions. Positive ions are cations and negative ions are anions. So you got to know that we have anions and cations. So all the time, when an element or a substance loses electrons, it will ionize. You know that when it loses electrons, it will become a cation. When it gains, it will either become an anion because it's gaining the electrons, and electrons are negatively charged. I just wanted you to remember all this which you have done as prior knowledge. Remember, we have group 1 to group 18 elements in the periodic table. The group 1 elements, they are able to produce a charge of positive 1, group 2 elements, positive 2, group 3 elements, positive 3. Meaning that your metals, like aluminium in group 13, is able to lose 3 electrons. So magnesium in group 2 is able to lose 2 electrons. Sodium in group 1 is able to lose 1 electron. These electrons are those ones that we refer to as valence electrons. Hence, we are saying that metals are good conductors of electricity and heat. So they have valence electrons. All metals have valence electrons between 1 and 3, which means a metal can lose 1 electron, 2 electrons, or 3 electrons. So they are good conductors. And these electrons, we say they are very loosely bound. So it's easy for metals to lose electrons. So when we refer to non-metals, we're talking about poor conductors. Remember, a plastic. So, for example, in this section, when you are having hydrogen, you'll have hydrogen gas and hydrogen ions. So you know you can't connect electricity to an ion or to gas. You will need platinum in order for electricity to be conducted. So it's very much important to understand that when we deal with this, we'll be dealing with metals and non-metals as well. Non-metals, they are between 4 and 7 valence electrons. This means that the electrons are firmly bound. So which means it's not easy for them to lose electrons. The non-metals, it's easy for them to gain electrons. So most of the time, under spontaneous reaction, you will find that the metals will lose electrons, the non-metals will gain electrons. However, we have graphite, which is carbon. Carbon is a non-metal, but it's a good conductor of electricity. So that's why when you are doing your experiment of copper chloride, electrolysis of copper chloride, you were able to use carbon there because it's a good conductor of electricity. So that is an exception. We said non-metals, they are not good conductors, but we're saying carbon is an exception because carbon is able to conduct electricity. Now, in the lower grades as well, grade 10 and 11, you have done the predictable. I'm reminding you again to say this, we call them group 1 elements. So these group 1 elements, it's easy for them to lose 1 electrons. Group 2 elements, 2 electrons. Group 13, as I indicated, like aluminium most of the time, is the one that we are interested in there. It will lose 3 electrons. And then we are saying as you move, group 18, which is the last group, is 0 because it cannot gain or lose electrons because it's fully filled. So we know that the noble gases are fully filled. They don't gain or lose electrons. They are unreactive because their outer energy level is fully filled with electrons. The group 17, they can gain 1. Hence, you will see most of the time we're going to talk about chlorine minus, which shows that chlorine has gained an electron. Remember, when sodium loses electrons, we said it becomes positive. So when it loses electrons, it becomes positive. But when chlorine gains electrons, it becomes negative. So when you see a negative charge, which we said is an anion, you must know that we have gained an electron. And when you see a positive charge, you must know that we have lost electrons. So when we lose electrons, it becomes positive, which is a cation. And when it gains electrons, an element gains electrons, it becomes negative, which we refer to as an anion. I hope that is clear, our learners, so that when you are in the exam, most of the time, you will be able to be asked questions on the charge that is found on sodium or on chlorine or on copper. So you got to know that the charge on chlorine will be negative. That of the metal will be positive charge. I hope we are together as far as that one is concerned. In grade 11, this is what you dealt with. You have done redox reactions. In grade 11, you defined oxidation as loss of electrons. You define reduction as gaining of electrons. So as this is a revision, I indicated that the focus for today will be mostly on problem solving. So I don't want to do more of teaching. I want us to go to problems to say when we get a problem like this, what is the strategy that we are going to use to solve the problem? So we're saying loss of electron is oxidation and gaining of electrons, we refer to it as reduction. So that is the first definition that you know, all of you must know. I hope even at school they emphasize that you must know these definitions. Loss of electron, we're saying, is oxidation. Gaining of electrons is reduction. So we are saying when a substance, like I gave a good example of sodium, when it loses electrons, it becomes a cation, which is a positive charge. So you must know that a cation or a positive charge shows that there was loss of electron, and we refer to that as oxidation. So all the time when you see a positive, you will know that. I emphasize that a lot because you got to know the difference between the two, that when you lose electrons, we're undergoing oxidation. Oxidation just indicates that there is increase in the oxidation number. So you can see the oxidation number of sodium was 0. There was nothing there. But now sodium has a positive, which means that it has increased in the oxidation number, which means that now sodium is now undergoing oxidation. So this sodium will refer to it as a reducing agent. So what is a reducing agent? Will be a substance that is going to undergo oxidation, or a substance that is going to lose electrons. So all the time, remember that Leora to say the reducing agent is a substance. Remember I said a substance can be an ion, a substance can be a compound, can be an element. So we're saying a reducing agent is a substance that undergoes oxidation, or a substance that loses electrons, or you can say a substance that is oxidized. So you got to know that all the time the substance that loses electrons is undergoing oxidation. We refer to it as a reducing agent and is oxidized. So all the time know that, so that because we are going to ask you which one is the reducing agent, so you must know that it's the one that is undergoing oxidation, or is the one that is oxidized, or is the one that is losing electrons. I hope I clarified that. The issue of reduction we're saying is gaining of electrons. A substance that gains electrons is undergoing reduction. We refer to that substance as an oxidizing agent. So oxidizing agent is a substance that undergoes reduction, or the substance that gains electrons. So these are 3 marks that you must get. And then, as I was indicating, this substance that gain electrons, because electrons are negatively charged, we'll say it becomes reduced. So you got to know that when a substance undergoes reduction, it will be reduced because it's gaining electrons which are negatively charged. So now, as well, you have to know what is an anode, what is a cathode. Remember, learners, we said an anode is a negative electrode. That is not a definition. It's a negative electrode. Is what an anode is. A cathode, you can see with the cat there, the positive T, you take T as your positive, then it shows that the cathode is a positive electrode. So we have a positive electrode, like you will do with any other cell. It will have a positive terminal and a negative terminal. So just think about any cell at home where you have a positive and a negative. So we're saying anode is the negative one, cathode is the positive one. I already defined for you the reducing agent and the oxidizing agent. I refer to oxidation numbers when I was indicating that when a metal loses electrons, when it becomes positive, that is oxidation number changes from 0 to positive. So immediately when there is that increase in the oxidation number, you know that that is loss of electrons. But when there is decrease in the oxidation number, you know that is gaining of electrons. I hope that is correct. And then you did in grade 11 as well, electrolysis of copper chloride, which is going to be examined this year as well. So I'm hoping that you'll get total in terms of this slide. Everything is clear for you. Now, without any wasting of time, I've explained all that. So remember these mnemonics, learners. These mnemonics are going to help us. Remember them during the exam to say, when you say for definitions, Leo, Rao, you are saying loss of electrons is oxidation. And the substance that undergoes oxidation, we said, is the reducing agent. So the thing that we are adding there is just that this is a substance. So you got to know that a reducing agent is a substance that undergoes oxidation. Already you are copying there. Once you know that mnemonic Leo Rao, you know that, okay, reducing agent, which is Ra, is the substance that undergoes oxidation, or the substance that loses electrons, or the substance that is oxidized. So you got to know how to define the reducing agent. When it goes to Gero, the next mnemonic there, we're saying gaining of electrons, we refer to it as reduction. So that is the oxidizing agent. What is oxidizing agent? Substance. You always refer to it as a substance that undergoes reduction, or a substance that gains electrons. So I hope this slide as well, it will help you. Remember, I said you got to know the definition of an anode. We said an anode is a negative. You can take A for A, then N for negative. A negative electrode, we call it anode. A positive electrode, we call it cathode. But the definition of anode is the electrode. Remember, is the electrode where oxidation takes place. So for you to remember, you'll say an ox, which means an anode, it will undergo oxidation. And for cathode, you'll say red cat to say a cathode will undergo reduction. So you got to remember all the time that the substance that undergoes reduction is our cathode. That's where they will be gaining of electrons. So you got to know that Leo Rao, which is the first mnemonic we had, is for the anode, and Gero, the second mnemonic there, is for the cathode. So you got to know that the cathode goes with that. So we're going to use a lot of this as you answer questions. So I will be moving just to give you a brief history of where this comes from. Remember, we're doing electrochemical cells. Electrochemical cell that converts chemical energy to electrical energy. So that is the definition of a galvanic cell. We refer to it as a galvanic cell or a voltaic cell. So we interchange the names. Don't have a problem of that. Sometimes we say voltaic cell or a galvanic cell. We're still referring to the same thing. This cell is spontaneous. Spontaneous means no electrical energy is added. So we're not going to add no energy. This will show you the difference between electrolytic cell as far and and galvanic cell. So we're saying galvanic cell is spontaneous, which means that no electrical energy is added. But when you go to electrolytic cell, which we'll do at the later part of this session, is that electrolytic cell, there will be now electrical energy added, which means when you add electrical energy, it won't be spontaneous, it will be non-spontaneous. That's why electrolytic cell was saying is non-spontaneous. But for galvanic cell, we refer to it as spontaneous because we are saying no electrical energy is added. It's exothermic because energy is produced during this reaction. This galvanic cell or voltaic cell, they are just named after these scientists, Galvani and Alessandro Volta. So those scientists are the ones that came up with this concept. So hence we refer to it as galvanic cell and Volta. We won't be asking you this in the exam. It's just for interest sake to say where the names are coming from. Now, in these ones, we are saying electrical current is generated from spontaneous redox reaction. So you know that there must be generation of electricity here. Now, a common apparatus that we use for galvanic cell. So this you got to know at all times. We must always have two different metals. So you will have a metal and another metal. So that is the first thing that you must have, two different, each immersed in separate beaker. So we must have two beakers. So we must immerse them like that. Then you know that, okay, when I even dilate them like that, it's a galvanic cell. They must contain their metal ions. For example, if this is zinc, it means the ion must be zinc 2 plus, which is zinc sulfate or zinc nitrate. We'll talk about that, the electrolyte. And then if this is copper, the electrolyte must be copper 2 plus, or which is copper sulfate or copper nitrate. We'll talk about the electrolyte as well. So we're saying they must be immersed in a solution. That solution, we refer to it as an electrolyte. What is an electrolyte? It's a solution that conducts electricity. So in the exam, that is an exam question. We can ask you to define what is an electrolyte. So you got to know that this is a solution that conducts electricity through the movement of ions. So we'll talk about that as well when we answer our question. As well, the other feature that is important for the voltaic cell is that we will have the salt bridge that is completing the circle. So the circuit. So you got to know that there must be a salt bridge that will go around there. I have a nice diagram than the one I showed, which is this one. So if we look, this is a good example of a galvanic cell. Now, remember, since this we're referring to it as redox, which stands for reduction oxidation. So because it's redox, it means one substance must undergo oxidation, one substance must undergo reduction. So they remember these two reactions takes place simultaneously, which means when one substance loses electrons, the other substance will gain those electrons. So that is what is happening. In this case, you are having in the anode, we are having zinc, which means zinc is going to lose electrons to form zinc 2 plus. And then copper 2 plus is going to gain electrons to form copper. So you got to understand that. And because the zinc solid, look at the face there, is solid, is becoming aqueous. So you can see that the mass will decrease. The mass of zinc will decrease because we're having a solid zinc that is becoming an aqueous solution. So you know that there will be decrease in mass of zinc. But now when we come to this side of the cathode where we have copper, the copper 2 plus, which is the solution, is becoming solid. So you can see that the solid, which is the mass, now will increase. So we are having change, physical change, because in the exam sometimes we'll ask you to explain the physical change that takes place during galvanic cell. So you got to know that on the side of the anode we will have the electrode, the electrode that is losing electrons, and on the side of the cathode the ion will be gaining electrons. So there will be decrease in mass, and a decrease in mass in the anode and increase in mass in the cathode. So the other thing which is of importance is to say, as zinc loses electrons to become zinc 2 plus and its mass is decreasing, what is increasing is the solution. The zinc 2 plus will increase. So the solution here, this side, will increase. Remember that solution we said is the electrolyte. So there will be increase in the concentration of the electrolyte. There will be increase in the concentration of the electrolyte. Sorry for that. Now we are saying as we move now, there are two things that happens on the anode. Note them. The mass of the anode in the anode side will decrease, and the concentration of the solution will increase. That is when we are having active electrode. Remember, sometimes the electrode must be active for it to be reduced in mass. So some of the electrode are not active, but I'll talk about that when we do our questions. So we are saying the mass decrease and the concentration increase on the side of the anode. On the side of the cathode, we are saying the mass increase, but the concentration of the electrolyte, of the copper 2+, will decrease. So as time goes on, you will see this light bulb will become dim, or it will switch off. It will become off. Then you will know that you have utilized all your solution. The concentration of the copper 2+ is finished. So when you don't have that concentration, the cell will cease to function. So you got to know that as the solution is decreasing, then it's going to affect the reaction as well. So I hope you have understood that. The other main thing was saying, know how to write the half reactions. Know how to write the half reactions. Then we know that you are not going to have a problem as well. So the half reaction on the anode, it must be loss of electrons, which is oxidation. We said is the reducing agent, and then it's oxidized. On the cathode, we are having gaining of electrons, which we said is reduction, and is the oxidizing agent is reduced. So you got to know that all the time, that's what is going to happen. When you have the two half reactions, you must be able to come up with the overall cell reaction, which means you must add the two half reactions to get what we refer to as a overall cell reaction. So you got to know that how to do that. I will explain in the following slides. Remember, I said the anode, because it's losing, we are having loss of electrons, it will decrease in mass. You can see our nice diagram there shows that there will be decrease in mass in our anode, which is the zinc. But we said the concentration of the zinc 2+, this solution concentration, we said it will increase because as it loses mass, it becomes aqueous. So it's not going away, it's only losing electrons, but it becomes part of the solution. So the solution will increase while the zinc is decreasing. But when you come this side of the copper, you can see there is increase in mass because the copper 2+, which is the solution, is becoming solid. So you can see that, the copper 2+ is becoming solid, hence there is increase in mass. But the concentration of the solution will decrease because it's all being converted to copper. I hope that slide will help you and you will remember it as you prepare for your exams. Now, I wanted here with this slide to further explain how the salt bridge function, because we are saying the salt bridge complete the circuit. That is the first function. The second one was the second one was saying it maintain electrical neutrality by allowing the movement of ions. So what I want you to understand here, we are having the anode, and let us don't make a mistake of thinking that the anode is always on the left. We can interchange them in the exam. We're going to talk about how do you know that this is the anode, this is the cathode. How do you identify the anode and the cathode? We're going to talk about that. So we're saying the anode, so don't cram to say on the left we always have anode, on the right we have cathode. No, that's not the case. We can put the cathode on the left and the anode on the other side. So we're having anode and cathode like that. Now, as you can look at the name itself, anode, so you got to know that An is from N ions. So the N ions will move this to the anode. So you just copy from the name. N ions, which is the negative charges. We talked about that. The negative charges will always move. The N ions moves to the anode. The cation ions moves to the cathode. In last year's paper, is one of the problems that our learners had. They were unable to know where will the flow of the cation ions and the N ions, the movement. So you got to know that in order to maintain electrical neutrality, N ions, which are the negative ions, will move to the anode, and the cation ions, which are the positive ions, they will move to the cathode. That one is a given. You must collect all the marks. Thank you. So I as well wanted to show you that cation ions, as you can see, I'm saying N ions plus electrode. So from the name itself, if you take the prefix An and the suffix ode, it gives you anode. So you got to know that our N ions electrode. So anode is where the N ions will flow to, and then cathode is where the cation ions will flow to. For you not to forget, Remember that positive, the T, take it as a positive so that it reminds you, when you see that T, it must remind you that the positive ions will go to the cathode. I hope I clarified the issue of the functioning of the salt bridge. Now, another 3 marks, this one of cell notation. Now, when it comes to cell notation, we are simply saying this is just a shorthand for representing a galvanic cell. So if you want to show a galvanic cell or voltaic cell with a shorthand, you will write it like that, which we refer to as cell notation. So if you can check, on the left we are having anode, in the middle we are having the bridge, and then on the right we are having the cathode. All the time when you write cell notation, it must always be ABC, which is the anode on the left, the salt bridge in the middle, and the cathode on the right. So when you are given like this, there is a question that I've seen that we're going to do today that talks to this as well, to say sometimes in the exam we can just give you a cell notation and ask you all the questions based on that. Don't think that all the time will be giving you the cell, the galvanic cell, and ask you the questions. We can give you the cell notation and ask you the question. We can give you the overall or the net cell reaction and ask you all the questions. So we'll look at those technicalities when you answer your questions so that you don't lose marks. So we're saying all the time, when you see a cell notation, you know already that we have the anode, the salt bridge, and the cathode. Look at this. If you look at the anode, we have a solid. At the cathode, we have a solid. All the time, we must have a solid at the outside of this cell notation. So we are saying on your left and on your right, you will have the solid. Sometimes you will find a reaction, like when you are having hydrogen. Hydrogen, you will find it as H2 and H plus. So it's hydrogen as a gas and hydrogen as aqueous solution. If you are having such a situation, you have to find a solid. In this case, you will go and use platinum, PT, which is solid. So when you don't have a solid, you will go and take platinum and use it as a solid. Please know that so that we don't have a problem. Remember the line, this solid line that separates zinc solid and zinc aqueous, the solid and the aqueous. This solid line shows you what we refer to as phase boundary. It shows you that we have a solid and an aqueous. So to separate them, you will write a solid line. Sometimes you will find, like in a case that I've seen of cobalt 3 plus and cobalt 2 plus, you can see all of them, they are plus. So when they are all plus, you won't put a solid line between them, because the solid line is showing that the two phases are different. But when they are all positive, they are all aqueous. So when they are all aqueous, you put a comma because they are in the same phase. Remember, we're saying a solid line shows you different phase. Now, when you put a comma there between them, you are saying these two are in the same phase. And because they are in the same phase, remember what we said, you must go and borrow platinum that you will use as your solid. I think I've talked to that and you have understood that when we don't have a solid, we'll use platinum as our solid. So at all times, remember that. And I said single line shows a phase boundary, and then the double line shows the salt bridge. So always when you're writing is A, B, C, you have the anode, the salt bridge, and the cathode on your right. I hope you have understood cell notation. Usually cell notation has 2 or 3 marks sometimes, depending. You can get 3 marks from that cell notation. Now there is this which we refer to as EMF of a cell. Now this is the maximum potential difference between 2 electrodes of a galvanic or voltaic cell. You see, we call it potential difference. Hence, when we calculate, is the difference is the E cathode minus E anode, because our EMF is the potential difference between the 2 electrodes. Our electrodes is a cathode and the anode. So when you find the difference between them, you are calculating the EMF. So at all times, know that to calculate the EMF, you have to find the difference between the cathode and the anode, not the other way around. Remember, if you can say E anode minus E cathode, it's not going to give you the correct answer. That's why we always emphasize to say copy the formula the way it appears on the formula sheet. So just go to the data sheet, look for the formula, copy it as is. Don't change anything on the formula, just copy it, then you write the formula as is. Already you have 1 mark. Remember, learners, if you just copy the formula, you don't substitute on it. We don't mark the formula. So don't lose that 1 mark that you are supposed to get for writing the formula. If you write the formula, by all means, there must be substitution of the numbers that you are getting from the table. Now we're saying the three formulas, you can choose any of the three, but it's always good as well to deal with the first one. It's simpler, you just copy it, then you write it, because already you've identified your cathode and your anode from the question. So we're saying if the cell potential is negative, the reaction is reversed. This is a good statement. I think it's something that you must always remember, because it's going to help you. You will see when you do questions. So when you go to the table, you will see, if you look at the cell potential, you find that it's negative, you know that the reaction is reversed, meaning that it will be the reverse reaction. That's the one that you will reverse. In the case, the electrode of the galvanic cell should be written in a reversed order. So you will write in a reverse order. I will show you how to do that. Then we'll talk about the standard cell potential. Is designated E of a cell. So E of a cell, that's what you'll use to calculate your EMF, and it's measured under standard conditions. Learners, these are free marks. So in the exam, we're asking you to name the standard conditions. Sometimes we ask you 2, sometimes we ask you 3, all of the 3. But now, most of the time, we ask you 2. For one reason, learners, to say, if, for example, we're dealing with zinc, zinc 2 plus, and then salt bridge, copper 2 plus, copper. You can see here, we have a solid outside, as we said that always we must have a solid in the cell notation. When we are having solids outside there, we wrote your solids, and we are having aqueous. The factors that will affect this reaction will be your temperature and initial concentration. Remember, learners, we use pressure when we are dealing with gases. So there's no gas in this reaction. So you can't now say 2 standard conditions are initial concentration of 1 mole per cubic decimeter and pressure of 101.3 kilopascals. That will be wrong because we don't have a gas. But in the case where I was talking about hydrogen and hydrogen ion, you can write any of the 3 will be correct. So most of the time, unless you are restricted to say don't write this one, write the other 2, then you will write the other 2. But if we say write 2, just write the first 2. You are most definitely more safe to get your 2 marks. So this one is just to remember. The mistake that you make during the exam is that you will write temperature, then you don't tell us how much temperature. When you say temperature, you don't tell us how much temperature. There's no difference, because maybe you are saying 100 degrees Celsius. So when you say temperature, you must say temperature of 25 degrees Celsius. If you like kelvins, you'll say 298 kelvins. And then when you say initial concentration, you will tell us that is 1 mole per cubic decimeter. When you say pressure, you'll say 101.3 kilopascals or 1 atm. Please, learners, I hope you understood me in terms of that. So you got to understand that our temperature is 25 degrees Celsius or 298 kelvins. Initial concentration is 1 mole per cubic decimeter. But if you have a gas, you can add a pressure as well to say pressure is 101.3 kilopascals, or you can say 1 atm. So I hope you have understood that and you don't have any problem. Now we going to the table of standard reduction potential. I will usually say to learners that this is a memorandum for this question. This is a memo, because if you understand well how to use this table, you will be able to get many answers done from this table. Let's look at the name itself. It says table of standard reduction potential. So it's a reduction potential. I usually will ask what is potential. You will say is ability. Then what is reduction? Is gaining of electrons. So I will say this is the table of ability to gain electrons under standard conditions. Remember the standard conditions, we just talked about them. We said temperature 25 degrees Celsius, initial concentration 1 mole per cubic decimeter, and we say pressure of 101.3 kilopascals or pressure of 1 atm. So we'll shortly come back after the break. I hope you enjoyed the first segment of this lesson, and let's meet immediately after this short break of 5 minutes. Thank you.
Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful, ubonge, leboha, be grateful each and every single day of your life. Strive to display an attitude of gratitude.
Do you know that you are different? Do you know that your fingerprint is different? It's different from your peers, from the people that you are studying with. So do not compare yourself with your peers. Do not compare your results with what they're getting, because you are different. You have your own talents and skills, and also you have your own gifts. Embrace what you can do. Always put in the work to make sure that your results become better than what they were yesterday. But do not compare yourself, because when you compare yourself, you do not know what another person has, and they do not have what you have. So believe in yourself. You are different, and keep on putting the work.
Welcome back. Our WhatsApp interactive number is still 064-748-8913. Hope you enjoyed your short break. So we're moving forward now. Remember, we were talking about the table of standard reduction potential. So I indicated that potential is the ability, and then reduction is gaining of electrons, which means this table is a table of ability to gain electrons. So at all times when you're using the table, you got to know that the one with the highest ability, the more positive number that we are having, it means it will undergo reduction, it will undergo gaining of electrons. So it means the ability to gain electrons is your standard, is your reduction potential. So that is the potential to gain electrons, or the ability to gain electrons. So all the time when you go to the table, you just look for the one with the highest ability. Then the one with the highest ability will gain electrons. The one with the lowest ability or lower ability will lose electrons. So the smaller one will lose, the bigger one will gain. For example, when we're talking about the copper and the zinc, you can see that because zinc is negative 0.76, it will lose electrons. But copper, because it has a higher ability to gain electrons, which is the higher standard reduction potential, which is positive 0.34, it will gain. So at all times, you're just looking at those numbers. You'll see when you go to the tables, you just look for those two numbers. The highest number will gain electrons, the lowest number will lose electrons. So I hope you understand that. Now we have two tables, if you can check, is table 4a and table 4b. Now what we are simply saying is that these tables are similar. The entries are arranged in opposite direction. So if you can check, you will see that the other table starts with positive numbers, it ends with negative numbers. The other one starts with negative numbers, it ends with the positive numbers. So the table basically the same, but sometimes for strategic reasons we advise you to use table 4b in galvanic cell, because you can see galvanic cell, you'll have a loss of electrons, which is happening. You can see table 4b, it starts with negative numbers. I'll show you the table now. It starts with negative numbers going to positive numbers. So it becomes easier for you if you are doing galvanic cell and you are using table 4b. However, you can use any other table to answer the question. So I hope I've clarified that one. There are four important things that you can use this table for. So if there is a question that says, identify the oxidizing and reducing agent, you can go to the table, it will help you. Identify the anode and the cathode. Remember, we said the more negative number will lose electrons, then the more positive number will gain electrons. So you can still use the table to identify anode and cathode. You can use it to write balance redox reactions. So you can see when you are saying write down the overall or the net cell reaction, you can go to the table, it will help you to do that. The fourth thing that you can use this table for is to predict whether a redox reaction is spontaneous or not. That is calculation of EMF. Remember, when EMF is positive, that is spontaneous. For galvanic cell, we're expecting our EMF to be positive. For electrolytic cell, because it's non-spontaneous, our EMF will be negative. Hence, we have to add energy. Hence, we said galvanic cell is spontaneous because no energy is added. We produce energy in galvanic cell. However, in electrolytic cell, we add energy because our EMF is negative. So we need energy to be added. So we use that table to be able to determine the EMF or to predict. So sometimes when you say calculate EMF, we'll simply say to yourself, predict whether a redox reaction is spontaneous or not. So when we're saying that, we're simply saying calculate EMF. If it's positive, it's spontaneous. If it's negative, it's non-spontaneous. Now, the standard reduction potential, it refers to the half fractions as reduction. Remember, the table is saying reductions. So hence, if you look on the left of the double arrows there for equilibrium, you will see that they are all gaining electrons. Hence, the table is referred to as standard reduction potential because they are all gaining electrons, or the electrons are on the left-hand side. Now, we are saying the E values or the standard reduction potential values therefore reflect the ability of the reactant to act as an oxidizing agent. So I indicated that already, or it shows which one will gain electrons. And we know that the one that gains electrons is the oxidizing agent. So when you look at the numbers, you see a more positive number, it tells you that is an oxidizing agent. You see a negative number, is a reducing agent. So it's easy to identify using the table because you just look at the standard reduction potential. Hence I said it's like it serves as your memorandum, because when you say which one is the oxidizing agent, which one is the reducing agent, you're able to go to the table and be able to identify the oxidizing agent and the reducing agent. And as I indicated, that the more positive E value, it will show which one will be oxidizing agent, and the more negative value will show the reducing agent. And we're saying each half reaction contains both a reducing agent and an oxidizing agent. I want you to understand this one, to say if we're having a reaction, in that reaction we'll have oxidizing agent and reducing agent. I will show you on the table. And then all the time you will have a stronger oxidizing agent reacting with the stronger reducing agent to form the weaker oxidizing agent and the weaker reducing agent. So all the time it's stronger oxidizing agent plus stronger reducing agent to form weaker oxidizing agent and weaker reducing agent. Now, a spontaneous reaction, I indicated, is the one that has a positive value, and a non-spontaneous has a negative answer. Now, here's our table, table 4a. So if you can look at table 4a, as I indicated, this is how you must read this table, learners. You must be able to say potential is the ability, reduction is gaining of electrons. So you know that this table is the table of gaining electrons under standard conditions. We talked about standard conditions. We said temperature is 25 degrees Celsius. We said initial concentration is 1 mole per cubic decimeter. And then lastly, we said pressure is 101.3 kilopascals or 1 atm. So you will all the time remember the standard. That standard stands for standard solution. That's why when we're writing the E of a cell, we'll have that 0 at the top with something inside there. That is indicating that that is under standard condition. That EMF was calculated under standard conditions, which means if the condition changes, even our EMF will change. Now, if we check our 4a, table 4a, as I indicated that we have two tables. It starts with the positive numbers, and at the end there we have more negative numbers. And if you look at the arrows, we're having two arrows here at the sides. I hope you can see them. Then it's saying as you go up the table, you are finding the stronger oxidizing agent. It says increasing oxidizing ability. So you know that as you go up this side, you have a stronger oxidizing agent, which means as you go down, you are having a weaker oxidizing agent. So you know that stronger as you go up, as you go down, you have weaker. So you know that on the left-hand side of this, on this table of these equations, we are having our oxidizing agent. What is different in them is the ability. The other one is stronger, the other ones are weaker. For example, you will see that F2 is a stronger oxidizing agent, whereas lithium is a weaker, lithium plus. Remember, is the issue of ions is important, because I'm saying in this in the direction of F2, let me try to write here, F2, which is a gas, plus 2 electrons forming 2F minus. When you're having that reaction, you will be able to know that, okay, in the same reaction, we're having oxidizing agent, which is F2. But on the right of the reaction, we're having a reducing agent. What is different is the strength. If you check, F2 is a stronger oxidizing agent because the arrow says so. So you know that F2 is a stronger oxidizing agent, whereas F minus, according to the arrow, stronger reducing agent is down here. Up there, it will be a weaker reducing agent. So you know that, okay, we are having a stronger oxidizing agent becoming a weaker reducing agent. So in the same reaction, so when you look at reaction, know that we are having reducing agent and oxidizing agent in the same reaction. What is different is the strength. So we're saying strong oxidizing agent as you go up, and on the left, on the right, you are having reducing agent. But if the strong, you have strong oxidizing agent, the reducing agent will be weaker according to these arrows. I hope you are able to understand that at all times, to say, okay, in one reaction, we're having the oxidizing agent and the reducing agent. What is different is the strength of the oxidizing agent and reducing agent. So you will see when you get questions that ask that, you got to be able to check at all times. So it doesn't help when you say which one is a oxidizing agent. You will say F2 because it's on the left. Which one, let's say here we can still, F minus will be a reducing agent, but it's a weaker reducing agent. So the question of weaker and strong, I hope I was able to stay on it and you have understood how to use the table to get that. Now, when you use table 4b, you are able now to see that, oh, it now starts with negatives. That's why we're advising you to use this table when you're dealing with a galvanic cell. Remember, we're doing the zinc copper cell, and then we had our zinc that was losing electrons. You can see we have zinc there. That becomes zinc 2 plus 2 electrons. That becomes, for you, it becomes zinc. So you got to know that. It's okay, zinc 2 plus like that, direction is written like that, and the standard reduction potential or ability to gain electrons is negative 0.676 volts. But when you look at copper 2 plus, you will see, and be careful learners, when it comes to copper, we have many coppers here. We have copper plus, we have another copper again, copper 2 plus, but it forms a copper plus, which is 0.16. We have another copper again, which is 0.34. So all the time, be careful which copper you're talking about, because we have 3 different coppers. So if you just in hurry to choose a copper, you will choose the wrong copper. In this case, we're talking about a copper 2 plus becoming copper. So you will choose copper 2 plus 2 electrons forming copper. I hope you understood that when we have more than one element or compound, you will look for the one that the question is asking about. So always look at the question to say, which copper am I going to look for in the table? Because in the question paper, it's like we're giving you an address to say, go to the table, go and look for this copper, go and look for this zinc. Then you copy them as I copied them like that. Then you know that the copper 2 plus is positive 0.34. And we said that the negative one will be reversed, meaning that this reaction, zinc will lose electrons, whereas copper 2 plus will gain electrons. So we're saying when you write zinc half fraction, you will write zinc losing electrons now. No longer gaining, but is now losing because it has a lower ability to gain electrons. Copper 2 plus, it has a higher ability to gain electrons, which is 0.34, so it will gain electrons, which means it will form copper 2 plus 2 electrons. That becomes copper. I hope you understood that. All the time when you're using the table, the first way to do it is to write the half fractions. Remember, the only time in the question, there is no time in the question where you will be writing double arrows. So when you take a reaction from the table, ensure learners that you already have made a decision whether it's a reverse reaction or it's a forward reaction, whether it's oxidation or reduction. Because when it's oxidation, which is the first one, you will write it like that, one arrow. And then when it's gaining of electrons, you will copy it the way it's copying, because the table already is reduction. So you just copy it as is. Then you make one arrow. So in your answers, don't write double arrow. All the time you are writing one arrow. There is nowhere where we will be asking you to write the double arrows. I haven't seen such a question, and I'm hoping that we won't be asking you to write them. So I say, make up your mind. Look, the most negative one, reverse the reaction. The most positive one, let the reaction go forward. You copy it as is. The only thing you are changing is that now we're using only one arrow, no more 2 arrows. So as you write them down, you are writing one arrow. Sometimes we use the method to say the Z method, where you can write Z there. You copy them, you go to table 4b, you copy them the way they are written. You see zinc comes first and then copper comes after. When you copy them, you write Z like that with arrows, with arrowheads there, with arrowheads. Then you are able to follow the arrowheads to say the first one will go backward, the second one will go forward. So when you're using table 4b for galvanic cell, you can apply this. It will always give you answers to say the first reaction that you get here is a reverse. The second one is a forward reaction. Yes. But we always teach you to understand. We don't want you to cram these things. We want you to understand. But if you do that, you are able as well to get your marks. So you will be able to write the 2 half fractions, which is 2 marks in your paper. When you are done with the half fraction, the 2 half fractions, remember we said you did the Z method, then you said A, and here you say C. You know that the first one is the what? Is the anode. The second one is the cathode. So all the time, if you are using this table, you will always know that the one at the top is the anode, the one at the bottom is the cathode. So you know that. Remember, we said this is your memorandum. And you know the anode undergoes oxidation. We said an ox and the cathode undergoes reduction. So you are able to tell that the one at the top will lose electrons, the one at the bottom will gain electrons. From there, you make a line. Remember, the first step, you copy them as they are. You do the Z to show that the first one will undergo reverse reaction, which is loss of electron, the second one reduction. After you copy them nicely. You said the first one is the anode, the second one is the cathode. So you write it like that. So immediately when you've done that, remember what we said when we started. We said loss of electron is oxidation, is the reducing agent, is oxidized. We said gaining of electrons is reduction, is the oxidizing agent, is reduced. So don't forget that. So all the questions we ask you, which one is the reducing agent? You know that this one, the anode, is the reducing agent. You can even go to the arrows, will tell you which one is the reducing agent. You look here. Oh, when you go up, we find the reducing agent, which is in this case is zinc. You see, the reducing agent is on the right. You can't write zinc 2 plus as your reducing agent. Zinc, this one is your reducing agent. And then which one is your oxidizing agent? Is this one. Remember what I said. A stronger reducing agent react with a stronger oxidizing agent to form the two weaker ones. So hence, when you write your overall, you'll say zinc. When you write overall, the first thing, look at the electrons. They must be equal. We have 2 electrons this side, 2 electrons this side. So you're able to cancel them. So what is on the right? On the left, you write on the left. On the left, we have zinc and copper 2 plus. Don't forget, we always write one arrow. When we're writing in the exam, we don't have to use 2 arrows. So the zinc plus copper 2 plus. On this side on the right, we have zinc 2 plus forming copper. So you're able to get a mark. Sometimes we give you 3, sometimes 2, depending on the examiners what they want. So you're able to write that as the overall cell reaction. From there, we said cell notation. Cell notation, you just look at this. Zinc becomes, remember I said A, B, C. So you will always start with the anode, which in this case was zinc. You say, okay, zinc, it becomes zinc 2 plus. Don't forget, the solid line shows that the two phases are different. It's a solid and an aqueous. Then we have a B for the salt bridge. You write the salt bridge. Remember the functions of the salt bridge to complete the circuit and to maintain electrical neutrality by the movement of ions. So you have the 2 lines, which is your B. Your C is the cathode, which is the second one there. We have your copper 2 plus becoming copper. So you can see these are your free marks to collect. We appreciate when you indicate the concentration of zinc 2 plus is 1 mole per cubic decimeter. Concentration of copper 2 plus is 1 mole per cubic decimeter. If you write it in brackets there, we'll appreciate that. But we'll still give you your marks. I hope that helps you in terms of using the table. And we said you can use the table to determine the reducing agent. So we are saying the anode and the cathode. You're able to say, okay, the first one is the anode, the second one is the cathode. Simple as that, as long as you are using the table. Which one is the reducing agent? You know the reducing agent. You just look at the arrow. The reducing agent, it's on the left. So you know it's zinc, the reducing agent. Which one is the oxidizing agent? Is copper 2 plus. You see now? We are strict on the charges. You can't say oxidizing agent is copper. It must be copper 2 plus. So you must take it for your half fractions. It's able to help you do that. So you are able to do what we refer to as overall cell reaction. Now, you have that which is just a simplified table. Maybe this one you can even see much clearly. So we are saying, look at nickel 2 plus. Its most negative reduction potential. So it's the strongest reducing agent. So you know that the one that is on the right is the reducing agent. So you know on the right we have reducing agent, on the left we have oxidizing agent. What differs is the strength. So you know that if the most negative one is a strongest reducing agent, then you will be having the most positive one as the weakest reducing agent. So as you move like that, remember on the right we have reducing agent, on the left we have oxidizing agent. What differs is the strength, and you look at the arrow to show which one is more positive or more negative. I hope I've stayed on the table and I've explained it, and I'm hoping it's going to help you when you write your exam. Now, question structures and tips. Now we're going to the bone of contention, where what are we supposed to do as we prepare for our final exam. We're saying the structure of the question will ask you about energy conversion. To say, define galvanic cell. Then you'll say it converts. It's a cell, electrochemical cell, that converts chemical energy to electrical energy. So that is the first thing that you must know. As you revise, I would like you to take a picture of this slide and know that this order is very much important. First thing, know energy conversion for both galvanic and electrolytic. Know the functions of the salt bridge. Know the movement of cations and anions. Remember, I said cations to the cathode, anions to the anode. So you do that, you are able to determine where this one will go. Know the standard conditions. Remember, the standard conditions I said is safe to write temperature, concentration. But when you have a gas and other maybe aqueous solution, you can immediately, when you have a gas, you can talk about pressure as well. So we have 3 standard conditions. Remember, I said when you say temperature, you must tell us 25 degrees Celsius. When you say concentration, you must say 1 mole per cubic decimeter, and pressure 1 atm or 101.3 kilopascals. Identify the anode and the cathode. I just showed you how to identify the anode and the cathode. Say, oh, anode is the most a negative electrode. So you just go there, you look for the negative one. You know it's your anode. You go to the table, you look for the most positive one. Table 4b, in this case, as I was using. Then you know that the most positive one must be your cathode. Now, you must be able to identify oxidizing agent and reducing agent. I showed you as well to say, okay, reducing agent, look at those arrows. They will tell you which one is the reducing agent, which one is the oxidizing agent. I hope that helps you. Write half reactions at the anode and at the cathode, or write oxidation half reaction, write reduction half reactions. So that is the question that is always there. Write overall or net reaction. Calculate EMF. These are the way we're expecting you to know all this in this fashion. And if you know all these bullets, you are sure of this question under galvanic cell, you will do very well. So I hope in terms of the question, the structure, and the tips that I've gave you under this is going to help you. Without any wasting of time, I can just, before we do a question, hence I said today we're going to do mostly spend our time doing questions. So exam tips, we're saying use single arrows. I'm emphasizing that again to say at no stage where we are asking you to write double arrows. So write our single arrows, then we are mostly safe. Do not omit charges. Learners, either it's an ion or an electron, positive ion or an electrons. Be able to show them. It can be positive ion or a negative ion. Show all those ions. They are important. Immediately you omit it, you are losing the marks. And we are saying when writing a formula for a 2-letter compound, for example, when you are having chlorine, Cl, you can't write 2 capital letters like that. That becomes wrong. The first one will usually be capital letter, but the second one won't be a capital letter. It will be a small letter. So we are saying that as a tip as well for your exam to say know at all times that the first one capital, the second one not capital. And they were saying if there are ions, indicate the ions. If there are electrons, indicate the electrons as well. When writing a reduction reaction, you only remove the arrow pointing backwards and write the equation as is, as I indicated. Because the table is a table of standard reduction potential, you just copy the equation as is, then you write your forward arrow when you write the reduction half reaction, and then you are able to get all your marks. Solutions in your half cell, this is important, learners. Is one of the challenges that we had in the past, where our learners, they don't know the electrolytes. So it's important for that, for every reaction, you know what electrolyte can be used there. So we're saying, for example, if we are having a zinc copper cell, we will use zinc sulfate. If we have zinc sulfate, we can't have a zinc sulfate and a copper nitrate. No, the solutions must be in the same solution. If it's a sulfate, it must be sulfate. Anions must be the same. If it's a sulfate, it must be sulfate in both of them. And remember, SO4 is a 2-, which makes the zinc to be zinc 2+ and the copper to be the copper 2+. So all the time when you see sulfate, you know that it's telling you the ion, that the cation is a 2+, because this is a 2-. Remember the oxidation numbers for a neutral compound, they must always add the oxidation numbers, they must add to 0. So if sulfate is always 2-, then you know that zinc will be 2+, so that when you add the charges there like that. So when you say zinc sulfate, you must see that it's zinc 2+ and SO4- is a copper 2+, and that. And then if you are using zinc chloride, you will use zinc chloride, will go with copper chloride. So we are saying you can't have at the anode an ion and a different ion from the one at at the cathode. So the anion must always be the same. Zinc chloride will go with copper chloride. Zinc sulfate will go with copper sulfate. I hope that will help you as you do your exams. Let's look at the paper. This is the paper that was written just last year. You can see there is a question. It was question 6. They set up the cell notation: zinc solid, phase boundary zinc 2 plus, then salt bridge copper 2 plus, then phase boundary copper solid. Represent a galvanic cell. So already they told you that this is a galvanic cell operating under standard conditions. So remember, you know the standard conditions, you know galvanic cell. So they said define the term galvanic cell. Remember, in my tips, I said to you the first thing, energy convention. So when you are defining, just tell us about energy convention to say in a galvanic cell, chemical energy will be converted to electrical energy. So you know that is from chemical energy to electrical energy. And then draw a labeled diagram to represent a zinc copper cell. This question, it was supposed to be simple, but our learners lost marks. Remember when I started, I told you that when you're drawing, you will draw the 2 beakers. Then you will have the salt bridge that joins them. You'll have the salt bridge, and inside there you must have electrode, which is your zinc electrode and your copper electrode. So you're supposed to do that and then indicate the movement. You can put a voltmeter there, indicate the movement of electrons to say, oh, if we're having zinc here, then the electrons are going to move that side from zinc to copper. So you're having copper here. The solution we said is copper 2 plus. Remember I said it can be a sulfate. If it's a sulfate, it must be sulfate in all of them. The electrolyte, we call it an electrolyte. Remember the definition of an electrolyte? We said it's a solution. It's a solution that conducts electricity. So it allows electricity to pass through it. So you were supposed to draw that, indicate your electrolyte as zinc sulfate on this one, or you are having zinc sulfate. On this one, you are having copper sulfate. Then you are having your salt there. It can be potassium nitrate or silver nitrate, whatever the salt that you are having there. And you can even show that, okay, on the anode, that's where the anion will go. That is NO3 minus will go that side. But I don't think we were penalizing you if you didn't show the movement. The cation goes to the cathode. So you were supposed to draw this and show that, okay, this is the anode, this is the cathode. And this was 5 marks. So learners were saying know how to draw the cells as well, because we don't know how the structure of the questions will be come the final exam when you write your paper. Now, look at the next question. It said, write down 2 standard conditions. Remember what I said. Write the first 2. Because we don't have any gas here, so you can't be talking to pressure. You will be able to say, we are having temperature, 25 degrees Celsius, initial concentration of 1 mole per cubic decimeter. You see, you'll just be collecting your marks. You can see all that is we are asking here is what we talked about in this lesson. So if really you go, you practice, you do as many questions as you can, so that at least you are able to collect these marks, then I know you will get total in this section. To which half cell do the anions? You see that questions comes again. Anions. I told you that anions plus electrode is anode. So you know anions, they go to the anode. Cations goes to the cathode. So you will answer that. Oh no, to which half cell do anions go? They'll go to the anode. So the anode is the zinc one. So they'll go to the zinc 2 plus cell, to this cell, the zinc one, the anode one. So you are able to know that they will come towards zinc. They will leave. The question was the anions, which is the negative ion. It goes to the anode. So you can see on the salt bridge, it will move like that. Don't confuse that with the movement of electrons. Remember, the electrons, they are moving in this circuit here, which is the external circuit. In the internal circuit, we are having the anions moving in the salt bridge. So remember that anions, they move, and cations, they move in the salt bridge, whereas the electrons, they move here on your conductor as they move from zinc to copper. Explain your answer to question 6.1.4. So you have to explain, or why are you saying that will happen? What are you saying? Why are you saying that the anions will move to the anode? So you got to be able to indicate that we are having here the zinc 2 plus. We are having zinc 2 plus. which makes this, remember, we said as the zinc loses electrons, the concentration will increase of zinc 2 plus. So as the concentration increases, the N ions are coming to neutralize these ones by forming your zinc nitrate solution there. So you got to know that the N ions will come and do what? And neutralize the positives that we're having. Since the electrons are moving towards the cathode, hence the potassium ions will come, because it's going to be more negative this side, because we're having more electrons coming this side. So the positive ion will go to the cathode. So all the time, know what happens with those movements. I hope we are still together. And then they said in this question, the anode in the zinc copper cell is replaced by an unknown electrode X. So you can see when we started with the zinc 2 plus, we had a salt bridge, we have the copper 2 plus copper. That's when we start. But now they are saying the anode, which is now your zinc, is now replaced by X. So we no longer know this. This is X, which will form X, whatever number of ions that X will have. Now, we got to understand that as now we have replaced the zinc and the zinc 2 plus, but for copper 2 plus, we know copper 2 plus is 0.34 from the standard reduction potential, 0.34 volts. Zinc was negative 0.76. You can see that's why we said the negative will lose electrons, the positive will gain the electrons. That's what was happening. Now when we replace, the voltmeter reading changes, it becomes 2 volts now, which means you are having EMF, which is E of a cell. Remember what we said is E cathode minus E anode. So you are able now to write E cathode minus E anode. So when we are saying that, we are simply saying by means of a calculation show. So you copy the formula. E of a cell you are given is 2 volts. So you will write 2 there equals to E cathode. You still know, you still are in this direction. Remember, they said identify the electrode by means of calculation. So you knew that this was 0.34. So you have the anode, which was this, which was 0.34. So there is change now. You are having 0.34 volts, but you no longer have that. So you have now to be able to go to the table and identify the electrode X. What will be the name of this electrode F as we do the question. So you will check there to say S. If we say okay, the 2.34, you go to the table, then it's going to help you to say what was there. Let me go back to the table to check what was the electrode that gave you that. So as you go, you will check, okay, if it was 2 minus 0.34, that will give you 1.66, negative 1.66. If it was 0.34 plus 2, then that will have given you 2.34. And you can see that you are having 2.36 according to this. You don't have any of that. So the only one that it makes sense to you, it will be 1.66, which is your aluminum. Then you are able to identify the unknown using that question. I hope that helps you to check that if you are given one electrode, you can be able to move from there. Yes. So I hope that helps you to say, when we say identify, we've given you another one. We're saying identify, then you are able to identify it using the table as well. Hence I said the table becomes your memorandum as well, to say as you go to the table, it will tell you the answer of your question. I hope that helps you. And then we are going to do another question, that is activity 2, which is, I think this was taken from KwaZulu-Natal. They wrote the paper, the prelim exam. So we just wanted to show you what others are doing as well. To say, look at the paper as well. They gave them X. They gave them X as a question to say, we're having X becoming X2 plus. we're having copper 2 plus becoming copper. So if you look at that question, you can see that, okay, the anode is X. We don't know what is the anode, but we know the double arrow stands for the salt bridge, and then this is our cathode. So you are able to see that, okay, we're having the anode which loses electrons and the cathode that gains electrons. They say state two functions of the salt bridge. Remember, this question is repeating. We talked about that. To complete the circuit, to maintain electrical neutrality by allowing the flow of electrons. State two conditions applicable to copper 2 plus copper half cell. So you will say initial concentration 1 mole per cubic decimeter, temperature 25 degrees Celsius. So you can see that these questions, they almost always repeat themselves. So if you have understood this, you will always get this. To which half cell do the cations in the salt bridge migrate? Remember, cations. So when you refer to cations, you remember I said cations always goes to the cathode. What is the polarity of the electrode X as well? So they're checking the polarity. So you know it's an anode, so it's negative, a negative electrode. You know that. We said A, negative. The N stands for negative electrode. For cathode, we said it's a positive electrode. It's a nice question as well. Is this unknown electrode X anode or cathode? Look at that question. Already you know that we said A, B, C. A, B, C. So you know on the left we're having the anode. So you were able to answer that question as well. And then they said the initial EMF reading. This question is it repeats that one as well. They are giving us again the E of a cell, which is in this case E of a cell is E cathode minus E anode. So you can see that, okay, you always copy the formula. You'll get 1 mark provided you're going to substitute on that formula. So you know that E of a cell is 1,1. But for copper is 0,34, and your copper was cathode, which is 0,34 minus E anode. So you're able to do that calculation as well. So still it's just maths that is left. Science is finished there. Then you just do your maths of saying 1,1, which is what the EMF of a cell that they've given us, and then 0,30 minus 0,34, because when it goes that side, the cathode now will go that side. So that will be 1,1 minus 0,34, which is your E anode. Don't forget 1,1, you can simply utilize your calculator. You have 1 minus 0,34. You do your math there. You're able to get your E of the anode, which is 0,66 plus 0,1. So that will be 0,77. 67 if not mistaken. So you are able now to get the value of the E anode, and then you are able to go and do your calculation. So without any wasting of time, I will take out my calculator and do the calculation for you, so that I'm able to give you the answer, which we said is 1,1 minus, we said it's 1,1 minus 0,34. That will give you the answer. 1,1 minus 0,34. That will give you the answer of 0,76. Oh, this one is a nice one. It goes straight to 0,76. Remember what is our 0,76? Remember we have the negative here. So you have to multiply both sides by negative to remove the negative this side. Then this will become negative 0,76, and then this will be positive. So you know negative 0,76, it's your zinc. So you know, you just go to the table, you look for that 0,76. So you're able to identify it. Let me rush to it so that you see that how to utilize the table. So when you go for negative 0,76, you are able to look for negative 0,76, and you get, oh, that's our zinc. So you're able to get what was our X. So you can see the zinc copper cell is a cell that you are going to work on. So I would like to thank you very much. I will see you on the last segment. We'll talk electrolytic cell and do the questions under electrolytic cell. I'll just wrap up this one, then we'll do electrolytic cell. Thank you very much. I hope I was Thank you. Welcome back. Our number is still the same. Our WhatsApp number is 064-748-8913. So I hope you were able to understand how we use the table and how we calculate the EMF, even when we are given an unknown. How do we go about finding that unknown? We have done this one. You were able to identify that your E of a cell, if I can just complete there, to say when you had your E of a cell there, you had your 0.34, then you were able to utilize it. So I'm hoping that was able to help you when dealing with the question. So we were able to do that and get our answer of 1.66, which we said is aluminium. So I hope that is going to be of help. On this question, we're able to calculate E of a cell, and they were able to identify that our E of a cell is our yes. I was just fixing that. Then you were able to see that copper, zinc is our anode. So you are always able to identify the unknown when you have that. Now we're going to talk electrolytic cell. Remember, electrolytic cell, we said is non-spontaneous, and we said is endothermic because we're going to add electrical energy. Remember, we said anode is a negative electrode, cathode is a positive electrode. Here, because we are using electricity, that changes. We say we have a positive anode. So the anode becomes positive and the cathode becomes negative because of the electrical energy. So don't confuse that. At all times, know that when you deal with electrolytic cell, because we are using electricity, you are forcing now your negative electrode to become the cathode, and your positive electrode to become the anode. So you are simply saying in other ways, when you are having chlorine, which is a non-metal, is going to gain electrons, and when you are having your copper, is going to copper is going to gain electrons and chlorine is going to lose them. Remember, we said because of electronegativity, the chlorine is able to gain electrons because it's more electronegative. But here, because we are using electricity, we are going to ensure that the one which is more electronegative now is the one that is going to lose electrons. But the one that was supposed to lose electrons is going to gain electrons, which in this case is our copper. So we're saying we're going to use electricity to force the negative electrode now to be the cathode and the positive electrode to be the anode. So we're saying still we'll have two electrodes, which is the anode and the cathode. The difference now is that anode is positive, cathode is negative. I want to emphasize that because that is one of the biggest mistakes that we make. And once you make that mistake, the whole question, you lose the marks. These electrodes are indicated, some are active, some are inactive. I will show you as we move. We define an electrolyte. We said it's a solution that conducts electricity through the movement of ions. The most important thing, you must know the formula of the electrolytes. I indicated the zinc sulfate, that it must go with the copper sulfate when you're dealing with the galvanic cell. So even here, we're still going to have an electrolyte, and then there will always be a source of direct current. So there will be a source of electricity. Some of the time we'll say, why do you say this is electrolytic cell? You will say, because of the source of direct current or a source of power that we're having. So we deal here with electrolysis of copper chloride solution. In this case, you are having the copper chloride, and then as indicated to you that if you go to the table of standard reduction potential, you will be able to see that copper is more positive than chlorine. Chlorine is more positive than copper. It was supposed to gain electrons, but in this case, because we are using electricity, you are having copper that is going to be formed at the cathode, and you are having chlorine gas that is formed at the anode. So if the solution on which electrolysis is being performed, it contains a halogen. So always just know when you say halogen, remember halogens are group 17 elements. We're saying halogens, they will always be in the anode, which means they will lose electrons. So chlorine is a halogen, it will lose electrons. If there is oxygen as well, it will lose electrons. So we're saying these most electronegative ones now, they're the ones that loses electrons because we are using electricity to force them to lose electrons. Now, in this case, chlorine will lose electrons as indicated. So you will have chlorine there losing the electrons as indicated. So we know that Our chlorine now will lose electrons. When chlorine loses electrons, it becomes Cl2. So the Cl2 gas will be formed. Copper 2 plus will gain those electrons and it becomes copper. So you see that at the anode there is formation of chlorine gas. At the cathode there is formation of copper. So you can see all the year we're using the same electrode, which we are saying is an inactive electrode. We refer to this as inactive because it's not taking part in the reaction. So for example, we're using carbon here. We can use carbon here, carbon electrode, carbon electrode. The reaction is taking place where we're having copper chloride, which is CuCl2. So we refer to this as electrolysis of copper chloride solution. We're saying solution because it's in water. So there is water inside here. But we're saying chlorine will be at the anode. Always halogens, they are anode. So don't forget, I'm emphasizing this, that when you see under electrolytic cell, when you see a halogen, when you see chlorine, know that it will always lose electrons. When you see your copper 2 plus now will gain electrons because chlorine is losing them. So halogens always losing the electrons. So we'll have the two half fractions where chlorine will lose electrons and those electrons will be accepted by copper 2 plus. So you are having copper 2 plus gaining electrons from chlorine, and then always overall cell reaction. We said what is on the left, you're right on the left. So it's copper 2 plus 2 chlorine minus, forming copper and chloride gas. So chlorine gas will be formed in this reaction. So this question was there even last year. We are hoping that when you see this question, you will understand it. Stay on it, understand. It's only 3 reactions that you are supposed to understand. The one at the anode, the one at the cathode, and the one at the overall cell reaction. So please go and spend your time doing this. The other reaction that you're expected to know is electroplating. So under electroplating, you will look at this. We are having a metal and an object. So we have two things. We have a metal, which is, I'll write as an M, and an object. What we have to know that the metal will be at the anode. The metal will always be at the anode. The metal is at the anode and the object is at the cathode. So you have to know that at the cathode we have the object. So the metal will lose electrons. Metal loses electrons, and see here now, it's no longer there. It's no longer the object that is gaining the electrons. It's the metal ions. So it's the silver losing electrons, but this silver, the same silver ion that is formed here, is the one that gains electrons here on the object, so that it can be plated on the spoon. So the spoon will become silver. So you have to understand that it is silver that loses electrons to become silver ion, but it's the same silver ion that gain an electron to become silver. So you can see that silver solid, the silver metal, it loses electrons to become an ion. Each metal ion is the one that gain an electron to become to be plated on the object. So electroplating works like that. We're saying don't forget, object at the cathode, anode is the what? Is the metal. So let's not forget. And I'm saying to you, look, remember this way is panic. So we're saying positive anode, positive anode. So you got to know that the positive one is the anode. Remember what I said? Anode, when we started, we said anode is negative. Now we're saying anode becomes positive. Why? Because we're using electricity to force the anode to become the negative electrode to become positive, to become the anode. So you got to know that the anode, this is your anode, is going to lose electrons, and then the cathode is going to do that. So don't forget that when you see all the time when you get the question, look at the positive and the negative. And remember, panic. Positive, you will say, is the anode. Negative is the cathode. You know at the anode, the reaction that takes place is oxidation, which is loss of electrons. At the cathode is reduction, which is gaining of electrons. I hope that will help you. Now, remember, we always ask you, what is the name of the electrolyte? So don't forget, when I'm doing this silver one, we'll use silver nitrate as the electrolyte. So you got to know that, okay, what is the electrolyte? We said it's a solution that conducts electricity. Remember, these questions, they are predictable. They're like that. So we're saying the first thing that you must know what is electrolysis or electrolysis. Know what is electrolytic cell. Electrolytic cell. So you can say define electrolysis, define electrolytic cell. Then you got to know that you are going to define them using energy convention. To say electrolysis is a process where electrical energy now is from E to C. You can see when write electrolysis, you start with E then to C. From electrical energy to chemical energy. What is electrolytic cell? It's a cell, electrochemical cell that converts electrical energy to chemical energy. What is electrolysis? It's a process that converts electrical energy to chemical energy. So always, because we have electricity, we are converting that energy, electricity, to chemical energy. So don't forget energy conversion. When I was giving you the strategy for the question, I said energy conversion is the first thing you must worry yourself about. The second thing that you must know is the definition of an electrolyte. What is an electrolyte? We said it's a solution that conducts electricity by allowing the movement of ions. We have our electrolyte here. Sometimes we'll ask you what is the name of the electrolyte used here. You must know is silver nitrate. So remember at all times that silver nitrate will be our electrolyte. Then you must know the two half reactions, to say oxidation, reduction. Then you are able to identify them. So all these will be able to be asked to you. Know that because silver is becoming silver ions, and silver ion is the one that is gaining electrons, we say the concentration of the electrolyte. So I'll use those brackets for the concentration, the square brackets. So the concentration of the electrolyte remains constant. The concentration of the electrolyte remains the same. Why the concentration of the electrolyte will remain the same? Because the rate of oxidation, don't forget, if you say oxidation is equals to or reduction, you are wrong. You must say the rate of oxidation is equals to the rate of reduction. So that is a 2-mark question that it goes with this question. Wherever this question goes with it. So know that we are saying the concentration of the electrolyte will remain the same because the rate of oxidation is equals to the rate of reduction. Simply because it's the silver that loses electrons to become silver ion. It's the same silver ion that gains electrons, which means there is no change now in the silver nitrate solution that is YAV. Hence, we are saying the concentration of the electrolyte remain the same. That is a free marks that you can collect for yourself. I hope that will help you as you prepare for your exam. Now, here is an activity borrowed as well from a prelim paper. So we are saying the electrochemical cell represented in the diagram below was used for the decomposition of molten copper to chloride. What happened here is, as the reaction proceeds, the following observations are noted as at electrode A and B. So you can see we have electrode A and electrode B. The only difference now is that in this question paper that they gave them here, they said molten. So I just brought this one to show you the difference between molten and solution. Because when we are talking about the molten one, we don't have it's not in water. We're not using water. We're just melting the copper chloride. So you got to know that the molten copper chloride, as the reaction proceed, we're having at A, there's a gas that is formed. You know there is only one gas that is formed, is chlorine. At B, there is a reddish brown layer that is formed. So you know the only layer that will be formed is copper. Copper 2+ is becoming copper. Then it will become brownish, this one. So those observations already, they tell you already what you are going to get. And remember I said a halogen, chlorine, is always at the anode. And hence this one will be cathode. So you know here there will be loss of electrons. Here there will be gaining of electrons. You can even go to table 4A and use it here to get the half reactions that will take place there. So it doesn't become a problem. You can use the same method that we have used when we were doing the galvanic cell, but using table 4A, because, for example, you will be able to see that, okay, you're going to have your chlorine at the anode losing electrons here, 2Cl-, then the copper 2+ gaining electrons to become copper. So I hope you are able to get that. Now, what type of electrochemical cell is represented in the diagram above? The type. You are going to say, okay, it is electrolytic cell. In other question papers, we'll ask you, why do you call it electrolytic cell? It's not because they are in the same beaker. The electrodes are in the same beaker. It's because we have a power source. So you got to refer to the power source, that we have a battery. That power source, it shows that we are now going to use electricity to force the negative electrode to become negative to become cathode and positive to become anode. So you are able to understand that. Write down the energy convention. You know, electrolytic cell, I told you, is always starting from energy convention. For electrolytic cell, we said it's from E to C. Don't forget that. From electrical to chemical energy. So you are able to collect that mark. Use the letters A or B to identify the following: anode and cathode. Already they said chlorine. We said chlorine is always in the anode. So you know anode A is anode and B is cathode. Write down the formula of the copper 2 chloride. You see, it's important that you know how to write copper 2 chloride. You can see in the whole question there is no copper 2 chloride. So you'll write copper Cl2. You are able to write copper 2 chloride. What is the oxidation number of the chloride ion? You see, when you say ion in copper 2 chloride, so you know chlorine group 17 elements, chlorine minus. So you are having a Cl minus, 2 Cl minus there. That is giving you the oxidation number, which is a negative 1. What happens to the mass of the anode as the reaction proceeds? State only increases, decreases, or remain the same. So you see now this becomes a tricky question to yourself to say, okay, we're having our anode here. Remember, we said the anode is the electrode that undergoes oxidation. So it's going to undergo we're going to have loss of electrons, which is oxidation. And then we said when we are losing electrons, there will be decrease on the mass. But now this question is very interesting because you are having your electrode here. Remember, we're having carbon, we're having another carbon. But now what is happening is that these carbons, they are inactive. They're not part of the reaction. So when you're choosing this answer to this question, you have to be very, very careful to look at that, to say if we are having now our carbon and carbon, which is our electrode, which are inactive, but however the chlorine, there is loss of electrons in the chlorine. So when you lose electrons, you will expect to say the answer is the mass will decrease because there is a loss of electrons. And then you will look at the mass, this mass increasing. The mass here, because the copper 2 plus will be that one. But now you are going to say it will decrease because you are losing electrons. Because it's a loss of electron, that will be oxidation. So when we lose electrons, we are decreasing the mass. So activity 2, in the electrolytic cell, 2 carbon rods are used as electrodes and concentrated copper 2 chloride solution is used. Now the difference between the cell we were doing and this one is that now this one is a solution. So the difference is that when it's a solution, we are saying it's a copper chloride in water. So we're saying it's a copper chloride in water. Define electrolyte, again, you'll say solution that conducts electricity. When the cell is in operation, a gas is released at electrode P. You know the gas that is released is Cl2. You know that it means we have chlorine this side and then we have copper on this side. Write down your half reaction to explain the observation at electrode P. So you will write the half reactions. Remember what I said. You can even go to the table 4A. I think we must go to that table so that it can help us to be able to answer that question. Now, when you go to the table, you have copper, you have chlorine. So you rush to the table as I'm trying to do the same now. Here's our table. Remember, for electrolytic cell, we will advise you to use table 4A. Now, when you look here, you are looking for copper and you are looking for chlorine. So you check, you go through your table, and then you are able to say, okay, I got copper 2 plus there. But it's the copper 2 plus with the plus. Remember I said we have 3 coppers. The copper that we are looking is the copper 2 plus, which is this one, 0.34. So please be aware of all the time to say which copper you are looking for. And then you are in need of your chlorine now, which will be here. Now remember what we said. You can just write your Z like that. When you write Z, the first reaction goes back. So you know that the chlorine, it will be 2Cl minus becoming Cl2 gas plus 2 electrons. And then on this one, you're leaving the copper 2 plus 2 electrons becoming copper. So you are able to know that, okay, the half fractions, you can take them straight from the table. So the table is your memorandum, as I indicated. Then you must be able as well to do what? You must be able to do the overall cell reaction. Remember, for the overall, we said the electrons, if they are equal, you must be able to cancel them. What is on the left, you write on the left. So you'll have a 2 chlorine plus your copper 2 plus. That is forming your Cl2 plus your copper. So that is able now to help you to get your overall, which is your other 2 marks that you can get. So that's how you will go about using the table 4A to help you answer that question. So immediately when you are given the copper chloride solution, just go to table 4A, and then you are saying the first reaction will be reversed, the second one will go forward. Already you got your marks. Remember, for the half fractions, I say when you copy these reactions, you copy them with 1 arrow to all the time, so you don't have a problem of that. So these are marks that you will collect by simply following that, and I hope that this will help you as we move forward. Now, as we go to the conclusion of our session, I hope all these tips are going to help you to answer the questions that you are going to come across during your final exam. Now, I'll just try to move faster. So don't forget, we are saying halogen is always anode. Halogen, always anode. Don't forget that. Chlorine, anode. Chlorine, anode. That must be your song. You know, chlorine is at the anode, and then the copper, in this case, copper 2 plus, will gain electrons. Now, we look at another example question. This one is on electroplating. Now, you can see now that under electroplating, we're saying the simplified diagram shows an electrolytic cell used as an electroplating company to coat iron metals with silver. Remember, we always said the metal will lose electrons. Where we have a metal, we're expecting to have loss of electrons. And where we have the object, we are simply expecting the metal ion. Remember, the iron metal, the object does nothing, it's inactive, it's not going to change anything. So we are going to have metal ion plus an electron forming a metal this side. So we are expecting that whatever the metal that we are having, which is this one, we're going to have loss of electrons by the metal. Where we have the object, the metal ion will gain the electrons. Now, state the direction of the electron flow. You know that the electrons will always come from the metal. So the first thing is to identify the metal, to say the metal will lose electrons. So the electrons will flow from your electrode Y to your iron metal, towards the iron metal. That's how the electrons will flow. What physical changes takes place at electrode Y? So you can see your silver is losing electrons. Your metal is losing electrons. Remember what you said. When it loses electrons, it's undergoing oxidation, it will decrease in mass. And they said physical, so you know that they were referring to the physical, what's happening, the change in the physical, which is decrease in mass because silver is losing electrons. What type of reaction, oxidation or reduction, takes place at the electrode Y? So you know electrode Y is a metal, it will be loss of electrons, which is oxidation. So you're just going to undergo oxidation. You just have to choose between the two. It's oxidation. Write down the equation of the half fraction that takes place at the iron metal. So you got to know that, okay, at the iron metal, because they told you already here that this is silver. So you're going to have a silver ion. Remember here, at the anode, silver loses electrons to become silver plus. Then the silver ion plus will gain electrons to become silver. So you have to think about this at all times, to say that here we're going to have silver ion gaining electrons, we're going to have silver losing electrons at electrode I. So where there is a metal, always there will be loss of electrons. Where there is an object, there will be gaining of electrons. Name or formula of electrolyte X. Remember, I always emphasize that to know the electrolyte, to say you will have here silver nitrate as your electrolyte. Give a reason. You remember I was talking about this in the last slide, to say why the concentration of the electrolyte remains constant. So that one you got to know at all times, to say what will make the concentration of the electrolyte to remain the same. We said the rate of oxidation is equals to, don't forget it's the rate of oxidation is equal to the rate of reduction. So the two rates are equal. That's why the concentration remains the same. I hope that helps you. You will have got total in that question. But under electroplating, we are not only doing electroplating using silver. It can be different. Like in this case, we're using nickel. We're using nickel as our electrode, as our metal. So you go to all the time. The strategy for this question is that all the time you just identify the metal. You know the metal will lose electrons, and then you know where we're having the object, they will be gaining of electrons. So it doesn't matter which metal you were given in the exam, the metal must lose electrons, and then where we're having the object, they must be gaining of electrons. So in this case, you will expect nickel. If you have forgotten how nickel loses electrons or gains them, just go to the table. You will get there's nickel there. You will see nickel is a 2+. So it's a nickel 2+ plus 2 electrons. How do you know that nickel is a 2+? Remember what I said, sulfate. Our electrolyte here is nickel sulfate. That sulfate, I said to you, SO4 is a 2-. When you remember the oxidation number. So at all the times, when you see that, okay, we're having a sulfate, you know that it's a 2-, which means that nickel is a 2+, because the 2+ and the 2-, they must cancel one another. So at all times, remember that to say when you're having a 2+, you must have a 2-, so that they're able to cancel. So you know that is nickel that is going to lose electrons. This side is nickel 2+. That is going to gain electrons to become nickel, which means now your plastic ring coated with graphite. Interesting. It's a plastic ring coated with graphite. You remember graphite is carbon. We said carbon is a non-metal, but it's a good conductor of electricity. So you won't expect a plastic ring to be able to conduct electricity. There won't be electron flow if you are using a plastic ring. Hence, we are going to cover the plastic ring with a graphite, with carbon, so that there is a conduction of a movement of electrons. I hope you understand that. So we are saying nickel 2+ will gain electrons on the object. Always the cathode is the object, and then the metal, where we are having the metal, we are able to see that our metal, we are going to have loss of electrons. So even when you look at the questions, they're going to ask the same questions that we have been asking, to say define the electrolyte, give one reason why plastic ring must be coated. I indicated this one to say we want conduction. There must be conduction. There must be a conductor of electricity. So if we don't have the conductor of electricity, obviously we're going to have a problem. That's why the plastic has to be coated with graphite, with carbon, which is a good conductor of electricity. There are fractions already. We've indicated that where you have the metal, there will be loss of electrons. Where there is a plastic, there will be gaining of electrons. So you can see that we are going to write these fractions. And look at those marks that you are supposed to collect. So I'm hoping that you are going to be able to collect all these marks as you get them in the paper. So we are saying focus on that and collect as many marks as you can. Now, the fraction that occurs at the plastic ring, we indicated. Name or formula of the reducing agent in the cell, and give the reason. Give the reason for the answer. Remember, we said loss of electron is oxidation. That's when we get our reducing agent, which is oxidized. So you will be able to know that nickel. Why is it? Are you saying it's a reducing agent? Because it's a substance that undergoes oxidation. It's the substance that is oxidized. It's the substance that loses electrons. So you are able to do that. And then they're saying which electrode, the ring or nickel, is the cathode. You know that always where we are having the object is a cathode. So you know that the cathode is the object. So don't forget that. I think I've emphasized that a lot. So you are able to collect all these marks. So as we go to the conclusion of our session, I would want you to always remember to say electrolysis of copper chloride. We have seen it can be molten, it can be a solution. So that is the difference. I just wanted to bring that to your attention as well, so that you are able to do that. I hope this is going to help you as you prepare for your exam. So that's what we are saying, to say please go and study. We are saying definitions. Remember at all times, all your definitions. You must get total. And we are saying use the exam guideline. As you prepare for your exam, go to the exam guideline. use it for the definitions. Then continuously know them in the right context, write them. You'll be able to collect as many 2 marks. Go to paper 1, November 2020, and paper 2, November 2020. You will see how many marks there were there in the definition. So we are always emphasizing. And the other emphasis that we are making is that the question of multiple choice questions. Spend some time there. Spend some time on multiple choice questions, then you know that you are going to collect as many marks as possible. Remember, according to the new exam guideline, this year we are going to have one-word questions or matching questions. So as well there, you will be using recalling and be able to answer those questions. So we're saying go prepare all these definitions, prepare multiple choice questions. Don't be in a hurry when you're answering your multiple choice questions. Make sure that as you answer your multiple choice questions, remember you are given 4 options. We're saying of the 4, 2 are disruptors. They're just there to disrupt you so that you don't get your marks. So we're saying please spend some time there. Remove the disruptors. Remain with the 2 options that are possible answers for your question. And I talked to this slide on structure of the paper. Please go stand on that one. No energy convention for galvanic and electrolytic cell. So as you are studying, put them aside and say this is what is different between galvanic and electrolytic cell. So we're saying for galvanic cell, energy conversion is from chemical to electrical energy. But for electrolytic cell, it's from electrical energy to chemical energy. Don't make a mistake of referring to mechanical energy, because you have done in paper 1, when you're doing motors and generators, you were doing mechanical energy. So some learners, they make a mistake of bringing mechanical. Remember, this is paper 2. We talk about chemical, not mechanical. So that is the first thing under energy convention. The functions of the salt bridge, we are overemphasizing that. The movement of cations. I'm again pleading with you, no cation to the cathode, anions to the anode. Standard conditions. We said there are 3 standard conditions, 2 almost always applicable. So if we say 2, to be safe, mention the first 2, which is your concentration of 1 mole per cubic decimeter, your temperature of 25 degrees Celsius or 298 kelvins. Identify the anode and the cathode. We're saying use the table. Go to the table. If it's galvanic cell, you know the negative is the anode, the positive is the cathode. But if it's electrolytic cell, because of the electricity that we are using, the positive becomes anode and the negative becomes cathode. You have seen with chlorine, now chlorine was losing electrons, becoming Cl2, and you saw that we had copper 2 plus gaining electrons to form copper. They said the brownish layer will be formed on the cathode there. Now we are saying to identify oxidizing agent and reducing agent, you can use the table as well. Go to the table. Look at those arrows. It will show you increasing ability of oxidizing agent, increasing ability of reducing agent. So we're saying the most negative one is a stronger reducing agent. The most positive one is the stronger oxidizing agent. So please, we're pleading with you to go and do that, and you will collect all these marks. There are reactions as well. I said it that under galvanic cell, the most negative, you will reverse the reaction. The most positive, you will write it as is. And as you copy from the table, ensure that you are copying only one arrow, the front arrow that you are writing for oxidation and for reduction. So I'm hoping that you won't be copying both the arrows, the 2 arrows there. You will make a choice to say this one is negative, it will lose electrons. This one is positive, it will gain electrons. Overall cell reactions, we're saying ensure that the electrons are balanced. For example, if you're having aluminium and zinc or copper or any other which is losing 2 electrons, you will multiply the 2 and the 3 so that the number of electrons must be balanced before you complete your overall cell reaction. So all the time, look at the number of electrons. They must be balanced when you write your overall net reaction. Calculation of the EMF, I'm saying please copy the formula from the formula sheet and substitute correctly. If when you are doing your calculation in a galvanic cell, you are getting a negative number, it will tell you something that is non-spontaneous. Remember, we're saying a positive EMF value, it shows you spontaneous, and a negative EMF value, it shows you non-spontaneous. I hope you have enjoyed this lesson. I hope you are going to prepare yourself. You are going to study paper 2 and be ready for for your certificate next year as you get your results. Or wishing you all the best. Thank you very much. And then we are saying thank you for watching this lesson. Please remember to sanitize, wear your mask, maintain social distancing, and keep safe. See you next time. Thank you very much.